Hello, everyone. We are getting started here on our August Lunch and Learn session presented by Kenning Group's Atlas Customer Experience team. My name is Alice Devaney. I'm the engineering manager for the Atlas Customer Experience team, and I'm excited to be presenting this month's session on intermediate level Splunk searching. So thank you all for attending. I hope you get some good ideas out of this, and certainly encourage engagement through the chat. And I'll have some information at the end on following up and speaking with my team directly on any issues or interests that you have around these types of concepts that we're going to cover today. So jumping into an intermediate level session, I do want to say that we have previously done a basic level searching session so that we are really progressing from that, picking up right where we left off. We've done that session with quite a few of our customers individually and highly recommend if you're interested in doing that or this session with a larger team, we're happy to discuss and coordinate that. So getting started, we're going to take a look at the final search from our basic search session. And we're going to walk through that, understand some of the concepts, and then we're going to take a step back, look a little more generally at SPL operations and understanding how different commands apply to data and really that next level of understanding for how you can write more complex searches and understand really when to use certain types of commands. And of course, in this session, we're going to have a series of demos using a few specific commands, highlighting the different SPL command types that we discussed in the second portion, and get to see that on the tutorial data that you can also use in your environment, in a test environment, very simply. So I will always encourage, especially with search content, that you look into the additional resources that I have listed here. The search reference documentation is one of my favorite bookmarks that I use frequently in my own environments and working in customer environments. It is really the best quick resource to get information on syntax and examples of any search command, and is always a great resource to have. The search manual is a little bit more conceptual, but as you're learning more about different types of search operations, it's very helpful to be able to review this documentation and have reference material that you can come back to as you are studying and trying to get better in writing more complex search content. I have also linked here the documentation on how to use the Splunk tutorial data. So if you've not done that before, it's a very simple process, and there are consistently updated download files that Splunk provides that you're able to directly upload into any Splunk environment. So that's what I'm going to be using today. And given that you are searching over appropriate time windows for when you download the tutorial data set, these searches will work on the tutorial data as well. So highly encourage after the fact, if you want to go through and test out some of the content, you'll be able to access a recording, as well as if you'd like the slides that I'm presenting off of today, which I highly encourage because there are a lot of useful links in here. Reach out to my team. Again, right at the end of the slides, we'll have that info. So looking at our overview of basic search, I just want to cover conceptually the two categories that we discuss in that session. And so those two are the statistical and charting functions, which consist of, in those demos, aggregate and time functions. So aggregate functions are going to be your commonly used statistical functions meant for summarization. And then time functions actually using the timestamp field, underscore time, or any other time that you've extracted from data, and looking at earliest, latest, relative time values in a summative fashion. And then evaluation functions are the separate type where we discuss comparison and conditional statements. So using your if and your case commands in evals. Also date time functions that apply operations to events uniquely. So not necessarily summarization, but interacting with the time values themselves, maybe changing the time format. And then multi-value eval functions. We touch on that very lightly, and it is more conceptual in basic search. So today we're going to dive in as part of our demo and look at multi-value eval functions later in the presentation. So on this slide here, I have highlighted in gray the search that we end basic search with. And so that is broken up into 3 segments, where we have the first line being a filter to a data set. This is very simply how you are sourcing most of your data in most of your searches in Splunk. And we always want to be as specific as possible. You'll most often see the logical way to do that is by identifying an index and a source type, possibly some specific values of given fields in that data before you start applying other operations. In our case, we want to work with a whole data set, and then we move into applying our eval statements. So in the evals, the purpose of these is to create some new fields to work with. And so we have 2 operations here. And you can see that on the first line, we're starting with an error check field. These are web access logs. So we're looking at the HTTP status codes as the status field. And we have a logical condition here. If we're greater than or equal to 400, we want to return errors. And so very simple example, making it as easy as possible. If you want to get specifics on your 200s and your 300s, it's the exact same type of logic to go and apply likely a case statement to get some additional conditions and more unique output in an error check or some sort of field indicating what you want to see out of your status codes. So in this case, simple errors, or the value of non-error if we have, say, a 200. We're also using a time function to create a second field called day. You may be familiar with some of the fields that you get out of by default for most any events in Splunk, and that they're related to breakdowns of the timestamps. You have day, month, and many others. In this case, I want to get a specific format for day. So we use a strict time function, and we have a time format variable here on the actual extracted timestamp for Splunk. So coming out of the second line, we've accessed our data. We have created 2 new fields to use, and then we are actually performing charting with a statistical function. And so that is using time chart. And we can see here that we are counting our events that actually have the error value for our created error check field. And so I'm going to pivot over to Splunk here, and we're going to look at this search. And I have commented out most of the logic. We'll step back through it. We are looking at our web access log events here, and we want to then apply our eval. And so by applying the eval, we can get our error check field that provides error or non-error. We're seeing that we have mostly non-error events. And then we have the day field. And so day is actually providing the full name of day for the timestamp for all of these events. So with our time chart, this is the summarization with a condition actually that we're spanning by default over a single day. So this may not be a very logical use of a split by day when we are already using a time chart command that is dividing our results by the time bin, effectively a span of 1 day. But what we can do is change our split by field to host and get a little bit more of a reasonable presentation. We were able to see with the counts in the individual days, not only split through the time chart, but by the day field, that we only had values where our matrix matched up for the actual day. So here we have our hosts 1, 2, and 3, and then across days counts of the error events that we observed. So that is the search that we end on in basic search. The concepts there being accessing our data, searching in a descriptive manner using our metadata fields, the index and the source type, the evaluation functions where we're creating new fields, manipulating data, and then we have a time chart function that is providing some summarized statistics here based on the time range. So we will pivot back, and we're going to take a step back out of the SPL for a second, just to talk about these different kinds of search operations that we just performed. So you'll hear these terms if you are really kind of diving deeper into actual operations of Splunk searching, and you can get very detailed regarding the optimization of searches around these types of commands and the order in which you choose to execute SPL. Today, I'm going to focus on how these operations actually apply to the data and helping you to make better decisions about what commands are best for the scenario that you have or the output that you want to see. And in future sessions, we will discuss the actual optimization of searches through this optimal order of functions and some other means. But just a caveat there that we're going to talk pretty specifically today just about these individually, how they work with data, and then how you see them in combination. So our types of SPL commands, the top 3 in bold, we'll focus on in our examples. The first of which is streaming operations, which are executed on individual events as they're returned by a search. So you can think of this like your evals. That is going to be doing something to every single event, modifying fields when they're available. We do have generating functions. So generating functions are going to be used situationally where you're sourcing data from non-indexed data sets. And so you would see that from either input lookup commands or maybe tstats, pulling information from the TSIDX files. And so generating the statistical output based on the data available there. Transforming commands, you will see as often as streaming commands, generally speaking, and more often than generating commands, where transforming is intended to order results into a data table. And I often think of this much like how we discuss the statistical functions in basic search as summarization functions, where you're looking to condense your overall data set into really manageable, consumable results. So these operations that apply that summarization are transforming. We do have 2 additional types of SPL commands. The first is orchestrating. You can read about these. I will not discuss in great detail. They are used to manipulate how searches are actually processed or how commands are processed. And they don't directly affect the results in a search, how we think about, say, applying a stats or an eval to a data set. So if you're interested, definitely check it out. Link documentation has details there. Data set processing is seen much more often, and you do have some conditional scenarios where commands can act as data set processing. So the distinction for data set processing is going to be that you are operating in bulk on a single completed data set at one time. So we'll look at an example of that. I want to pivot back to our main 3 that we're going to be focusing on, and I have mentioned some of these examples already. The eval functions that we've been talking about so far are perfect examples of our streaming commands. So where we are creating new fields for each entry or log event, where we are modifying values for all of the results that are available. That is where we are streaming with the search functions. Input lookup is possibly one of the most common generating commands that I see because someone is intending to source a data set stored in a CSV file or a KV store collection, and you're able to bring that back as a report and use that logic in your queries. So that is not requiring the index data or any index data to actually return the results that you want to see. And we've talked about stats very generally speaking, with a lot of unique functions you can apply there, where this is going to provide a tabular output, and it is serving that purpose of summarization. So we're really reformatting the data into that tabular report. So we see in this example search here that we are often combining these different types of search operations. So in this example that we have, I have data that already exists in a CSV file. We are applying a streaming command here where evaluating each line to see if we match a condition and then returning the results based on that evaluation. And then we're applying a transforming command at the end, which is that stats summarization, getting the maximum values for the count of errors and the host that is associated with that. So let's pivot over to Splunk and we'll take a look at that example. So I'm just going to grab my search here, and I've pre-commented out the specific lines following input lookup, just to see that this generating command here is not looking for any specific index data. We're pulling directly the results that I have in a CSV file here into this output. And so we have a count of errors observed across multiple hosts. Our where command, you might think is reformatting data. In this sense, it is transforming the results, but the evaluation of a where function does apply effectively to every event that is returned. So it is a streaming command that is going to filter down our result set based on our condition that the error count is less than 200. So the following line is our transforming command, where we have two results left, 187 for host 3. We want to see our maximum values here of 187 on host 3. So our scenario here has really covered where you may have hosts that are trending toward a negative state. You're aware that the second host had already exceeded its threshold value for errors, but host 3 also appears to be trending toward this threshold. So being able to combine these types of commands, understand the logical condition that you're searching for, and then also providing that consumable output. So combining all three of our types of commands here. So I'm going to jump to an SPL demo. And as I go through these different commands, I'm going to be referencing back to the different command types that we're working with. I'm going to introduce in a lot of these searches a lot of small commands that I won't talk about in great detail. And that really is the purpose of using your search manual, using your search reference documentation. So I will glance over the use case, talk about how it's meant to be applied, and then using in your own scenarios where you have a problem you need to solve, referencing the docs to find out where you can apply similar functions to what we observed in the demonstration here. So the first command I'm going to focus on is the rex command. So rex is a streaming command that you often see applied to data sets that do not fully have data extracted in the format that you want to be using in your reporting or in your logic. And so this could very well be handled actually in the configuration of props and transforms and extracting fields at the right times and indexing data. But as you're bringing in new data sources, you need to understand what's available for use in Splunk. A lot of times you'll find yourself needing to extract new fields in line in your searches and be able to use those in your search logic. Rex also has a SED mode that I also see testing done for masking of data in line prior to actually putting that into indexing configurations. So Rex you would generally see used when you don't have those fields available. You need to use them at that time. And then we're going to take a look at an example of masking data as well to test your syntax for a SED style replace in config files. So we will jump back over. So I'm going to start with a search on an index source type, my tutorial data, and then this is actual Linux secure logging. So these are going to be OS security logs. And we're looking at all of our web hosts that we've been focusing on previously. In our events, you can see that we have first here an event that has failed password for invalid user INET. We're provided a source IP, a source port, and we go to see the fields that are extracted, and that's not being done for us automatically. So just to start testing our logic to see if we can get the results we want to see, we're going to use the rex command. And in doing so, we are applying this operation across every event, again, a streaming command. We are looking at the raw field. So we're actually looking at the raw text of each of these log events. And then the rex syntax is simply to provide in double quotes a regex match. And we're using named groups for field extractions. So for every single event that we see failed password for invalid user, we are actually extracting a user field, the source IP field, and the source port field. For the sake of simplicity, I tried to keep the regex simple. You can make this as complex as you need to for your needs, for your data. And so in our extracted fields, I've actually pre-selected these so we can see our user is now available. And this applies to the events where the regex was actually valid and matching on the failed password for invalid user, etc. string. So now that we have our fields extracted, we can actually use these. And we want to do a stats count as failed logins. So anytime you see an operation as and then a unique name, just a rename through the transformation function, easier way to actually keep consistency with referencing your fields, as well as not have to rename later on with some additional, in this case, you'd have to reference the name distinct count. So just a way to keep things clean and easy to use in further lines of SPL. So we are counting our failed logins. We're looking at the distinct count of the source IP values that we have. And then we're splitting that by the host and the user. So you can see here, this tutorial data is actually pretty flat across most of the sources. So we're not going to have any outliers or spikes in our stats here. But you can see the resulting presentation. In line 4, we do have a sort command. And this is an example of a dataset processing command where we are actually evaluating a full completed dataset and reordering it. Given the logic here, we want to descend on these numeric values. So keep in mind, as you're operating on different fields, it's going to be the same sort of either basic numeric or the lexicographical ordering that you typically see in Splunk. So we do have a second example with the SED style replace. So So you can see in my events here, we are searching the tutorial and vendor sales index and source type. And I've gone ahead and applied one operation. And this is going to be a helpful operation to understand really what we are replacing and how to get consistent operation on these fields. So in this case, we are actually creating an ID length field where we are going to choose to mask the value of account ID in our rex command. We want to know that that's a consistent number of characters through all of our data. It's very simple to spot check, but just to be certain, we want to apply this to all of our data. In this case, streaming command through this eval. We are changing the type of the data because account ID is actually numeric. We're making that a string value so that we can look at the length. These are common functions in any programming languages. And so the syntax here in SPL is quite simple. Just to be able to get that contextual field, we understand we have 16 characters for 100% of our events in the account IDs. So actually applying our rex command, we are going to now specify a unique field, not just underscore raw. We are applying the sed mode, and this is a sed syntax replacement, looking for the, it's a capture group for the first 12 digits. And then we're replacing that with a series of 12 X's. So you can see in our first event, the account ID is now masked. We only have the remaining 4 digits to be able to identify that. And so if our data was indexed and is appropriately done so in Splunk with the full account IDs, but for the sake of reporting, we want to be able to mask that for the audience, then we're able to use the sed replace. And then to finalize a report, this is just an example of the top command, which does a few operations together and makes for a good shorthand report, taking all the unique values of the provided field, giving you a count of those values, and then showing the percentage of the makeup for the total data set that that unique value accounts for. So again, pretty flat in this tutorial data, in seeing very consistent 0.03% across these different account IDs. So we have looked at a few examples with the rex command, and that is, again, streaming. We're going to look at another streaming command, which is going to be a set of multi-value eval functions. And so again, if you're to have a bookmark for search documentation, multi-value eval functions are a great one to have because when you encounter these, it really takes some time to figure out how to actually operate on data. And so the multi-value functions are really just a collection that, depending on your use case, you're able to determine the best to apply. You see it often used with JSON and XML, so data formats that are actually naturally going to provide a multi-value field where you have repeated tags or keys across unique events as they're extracted. And you often see a lot of times in Windows event logs, you actually have repeated key values where your values are different and the position in the event is actually specific to a condition. So you may have a need for extraction or interaction with one of those unique values to actually get a reasonable outcome from your data. And so we're going to use multi-value eval functions when we have a change we want to make to the presentation of data, and we're able to do so with multi-value fields. This, I would say, often occurs when you have multi-value data, and then you want to be able to change the format of the multi-value fields there. And then we're also going to look at a quick example of actually using multi-value evaluation as a logical condition. So the first example, we're going to start with a simple table looking at our web access logs. And so we're just going to pull in our status and refer domain fields. And so you can see we've got a HTTP status code, and we've got the format of a protocol subdomain, domain TLD. And our scenario here is that for simplicity of reporting, we just want to work with this refer domain field and be able to simplify that. So in actually splitting out the field, in this case, split refer domain, and then choosing the period character as our point to split the data, we're creating a multi-value from what was previously just a single value field. And using this, we can actually create a new field by using the index of a multi-value field. And in this case, we're looking at index 0, 1, 2. The multi-value index function allows us to target a specific field and then choose a starting and ending index to extract given values. There are a number of ways to do this. In our case here, where we have 3 entries, it's quite simple just to give that start and end of range as the 2 entries apart. So as we are working to recreate our domain, and so that is just applying for this new domain field, we have buttercupgames.com in what was previously the HTTP www.buttercupgames.com. We can now use those fields in a transformation function, in this case, a simple stats count by status in the domain. So I do want to look at another example here that is similar, but we're going to use a multi-value function to actually test a condition. And so I'm going to, in this case, be searching the same data. We're going to start with a stats command. And so a stats count as well as a values of status. And so the values function is going to provide all the unique values of a given field based on the split by. And so that produces a multi-value field here. In the case of status, we have quite a few events that have multiple status codes. And as we're interested in pulling those events out, we can use an MV count function to evaluate and filter our data set to those specific events. So a very simple operation here, just looking at what has more than a single value for status, but very useful as you're applying this in reporting, especially in combination with others and with more complex conditions. So that is our set of multi-value eval functions there as streaming commands. So for a final section of the demo, I want to talk about a concept that is not so much a set of functions, but really enables more complex and interesting searching and can allow us to use a few different types of commands in our SPL. And so the concept of sub-searching for both filtering and enrichment is taking secondary search results and we're using that to affect a primary search. So a sub-search will be executed, the results returned, and depending on how it's used, this is going to be processed in the original search. And that is going to, we'll look at an example that it is filtering. So based on the results, we get effectively a value equals X or value equals Y for one of our fields that we're looking at in the sub-search. And then we're also going to look at an enrichment example. So you see this often when you have a data set maybe saved in a lookup table, or you just have a simple reference where you want to bring in more context, maybe descriptions of event codes, things like that. So in that case, we'll look at the first command here. Now I'm going to run my search, and we're going to pivot over to a sub-search tab here. And so you can see our sub-search, looking at the secure logs. We are actually just pulling out the search to see what the results are, or what's going to be returned from that sub-search. So we're applying the same recs that we had before to extract our fields. We're applying a where, a streaming command, looking for anything that's not null for user. We observed that we had about 60% of our events that were going to be null based on not having a user field. And so looking at that total data set, we're just going to count by our source IP. And this is often a quick way to really just get a list of unique values of any given field, and then operating on that to return just the list of values. A few different ways to do that. See stats count pretty often. And in this case, we're actually tabling out just keeping our source IP field and renaming to client IP. So the resulting data set is a single column table with 182 results. And the field name is client IP. So when returned to the original search, we're running this as a sub-search, the effective result of this is actually client IP equals my first value here, or client IP equals my second value, and so on through the full data set. And so looking at our search here, we're applying this to the access logs. You can see that we had a field named source IP in the secure logs, and we renamed a client IP so that we could apply this to the access logs, where client IP is the actual field name for the source IP data. And in this case, we are filtering to the client IPs relevant in the secure logs for our web access logs. So uncommenting here, we have a series of operations that we're doing, and I'm just going to run them all at once and talk through that we are counting the status, or we're counting the events by status and client IP for the client IPs that were relevant to authentication failures in the secure logs. We are then creating a status count field just by combining our status and count fields, adding a colon between them. And then we are doing a second stats statement here to actually combine all of our newly created fields together in a more condensed report. So transforming command, then streaming for creating our new field, another transforming command, and then our sort for data set processing actually gives us the results here for a given client IP. And so we are, in this case, looking for the scenario that these client IPs that are involved in authentication failures to the web servers, in this case, these were all over SSH. We want to see if there are interactions by these same source IPs actually on the website that we're hosting. So seeing a high number of failed values, looking at actions also as a use case here for just bringing in that context and seeing if there's any sort of relationship between the data. This is discussed often as correlation of logs. I'm usually careful about using the term correlation in talking about Splunk queries, especially in enterprise security, talking about correlation searches, where I typically think of correlation searches as being overarching concepts that cover data from multiple data sources. And in this case, correlating events would be looking at unique data types that are potentially related and finding that logical connection for the condition. That's a little bit more up to the user. It's not quite as easy as, say, pointing to a specific data model. So we are going to look at one more sub-search here, and this case is going to apply the join command. And so I talked about using lookup files or other data returned by subsearches to enrich, to bring more data in rather than filter. We are going to look at our first part of the command here. And this is actually just a simple stats report based on this rex that keeps coming through the SPL to give us those user and source IP fields. So our result here is authentication failures for all of these web hosts. So similar to what we had previously returned. And then we're going to take a look at the results of the subsearch here. I've actually split this up so that we can see the first two lines. We're looking at our web access logs for purchase actions. And then we are looking at our stats count for errors and stats count for successes. We have pretty limited status codes returned in this data. So this is viable for the data present to observe our errors and successes. And then we are actually creating a new field based on the statistics that we're generating, looking at our transaction errors. So where we have high or low numbers of failed purchase actions, and then summarizing that. So in the case of our final command here, another transforming command of table, just to reduce this to a small data set to use in the subsearch. And so in this case, we have our host value and then our transaction error rate that we observed from the web access logs. And then over in our other search here, we are going to perform a left join based on this host field. So you see in our secure logs, we still have the same host value. And this is going to be used to actually add our transaction error rates in for each host. So as we observe increased authentication failures, if there's a scenario for a breach and some sort of interruption to the ability to serve out or perform these purchase actions that are affecting the intended operations of the web servers, we can see that here. Of course, in our tutorial data, there's not really much that's jumping out or showing that there is any correlation between the two. But the purpose of the join is to bring in that extra data set to give the context to further investigate. So that is the final portion of the SPL demo. And I do want to say, for any questions, I'm going to take a look at the chat. I'll do my best to answer any questions. And then if you have any other questions, please feel free to reach out to my team at support@kinneygroup.com, and we'll be happy to get back to you and help. I am taking a look through. Okay, seeing some questions on performance of the rex, sed, regex commands. So off the top of my head, I'm not sure about a direct performance comparison of the individual commands. Definitely want to look into that, and definitely follow up if you'd like to explain a more detailed scenario or look at some SPL that we can apply and observe those changes. The question on getting the data set, that is what I mentioned at the beginning. Reach out to us for the slides, or just reach out about the link and the Splunk tutorial data. You can actually search that as well. And there's documentation on how to use the tutorial data. One of the first links there takes you to a page that has, it is a tutorial data zip file and instructions on how to ingest that. It's just an upload for your specific environment. So in add data and then upload data, 2 clicks and upload your file. So that is freely available for anyone. And again, that package is dynamically updated as well. So your timestamps are pretty close to normal as you download that. Kind of depends on the time of the the cycle for the update. But search overall time, you won't have any issues there. And then, yeah, again, on receiving slides, reach out to my team, and we're happy to provide those, discuss further, and we'll have the recording available for this session. You should be able to, after the recording processes, when the session ends, actually use the same link, and you can watch this recording in post without having to sign up or transfer that file. So, okay, Chris, seeing your comment there. Let me know if you want to reach out to me directly, anyone as well. We can discuss what slides and presentation you had attended. I'm not sure I have the attendance report for what you've seen previously, so happy to get those for you. All right, and thanks, Brett. So you see Brett Woodruff in the chat commenting, systems engineer on the expertise on demand team. So very knowledgeable guy, and he's going to be presenting next month's session. That is going to take this concept that we talked about, the sub-searching as a just general search topic. He's going to go specifically into data enrichment using joins, lookup commands, and how we see that used in the wild. So definitely excited for that one. Encourage you to register for that event. All right. I'm not seeing any more questions. All right. With that, I am stopping my share. I'm going to hang around for a few minutes, but thank you all for attending, and we'll see you on the next session.